Alright, in this video I'm going to show how to conduct a linear regression using dummy variables. In the last video I showed how to create dummy variables, you get. So in some old versions of SPSS, you see that you have to create dummy variables through recoding, but in the new versions now, they will just put you just see where to create it directly in a transform. You don't need to go or do processes of recoding and the transformation. You just see it somewhere here in this, under this transform drop down menu in new versions, but I know majority make use of old versions, so that was why I decided to show how it is being created through this recoding into different variables, you get. So but now I want to show how to conduct a regression analysis, linear regression. You know, we have two types of linear regression. We have a simple linear regression and a multiple linear regression. So when you have only one predictor variable, so we call it a simple linear regression. But when you have more than one predictor variables, you refer to it as a multiple or multilinear regression. Multiple linear regression, you get, once the dependent variable, also called the outcome variable, and the predictor variables in continuous form referring to linear regression. That's what we're going to conduct. So in this case now, we want to we've created 4 dummy variables, just as I told you. It's a continuation of the previous video. So, and we want to know whether these 4 variables are good predictors of body mass index, you get. So you come to analyze, you come to regression, so linear, come to linear regression. So our dependent variable, also called the outcome variable, is body mass index. So you move it to the dependent, then you move our four predictor variables from single through widow to independence. So having done this, statistics, that's plots, and save, maybe it's this, and okay, return standardize, continue, options, leave it at that probability level, okay, bootstrap, now you click OK. So we wait for the output, and now this is the output. So you can see the ANOVA table to get. So the model explains the statistically significant amount of variance in the outcome variable, and that is why the p-value, the probability value, is significant, because it is less than 0.05. But looking at the R-square, you know, the higher the R-square, the better the predictive values of the coefficients. Looking at this R-square now, we have 0.133, which is 13.3% of the outcome variable, the variance in outcome variables. So, which is actually low. And coming to these coefficients, you can see that it's reflected. You understand? None of the variables is a good predictor. None of them is a predictor of the outcome variable BMI. You see, because looking at that of single, I have to know that this widower here is just to show you that just the comparison of a single and widower. The main thing, you know, widower is just the reference variable. So the main thing you are looking at here is single, you get. So this widower here is just to show you that it is a baseline. If you look at it, all of them has it: single and widow, married, widow, divorce and widow, widow and widow. So what you are referring to here particularly is all this first one: single, married, divorce and widow. So this shows that being single is not a predictor of body mass index. Then being married is not a predictor. Being divorced is not a predictor, and likewise being a widow. So marital status, considering with respect to this data set, is not a good predictor of body mass index. So that is just it. So thanks for watching.